GCOS has just released its latest status report on the Global Climate Observing System in 2021. This has come at a time when the demand for information about climate is increasing dramatically. To date, the Global Climate Observing System has been very successful. It has allowed the IPCC and other scientists to identify climate change, attribute it to human activities, and to produce projections of future change. However, now that the frequency of extreme weather events is increasing, with increasing vulnerability to people, and with the focus in the UNFCCC Paris Agreement on adaptation and mitigation, there is a need for even higher resolution and higher accuracy climate observations. These observations are needed to enable us to deliver climate services to produce effective decision-making and action, in particular adaptation and mitigation, at national level. This is supported by a chain leading from global observation systems that are freely and openly exchanged across the globe, that drive global climate modelling, which in turn is used as the basis for producing downscaled local models, local forecasts, warnings and advisories, which can then be delivered to a variety of users and support decision-making and action. The GCOS Status Report itself has been produced by drawing upon the expertise of a wide range of people, from the GCOS expert panels, through National Meteorological and Hydrological Services and the Global Ocean Observing System, satellite agencies coordinated by CEOS and CGMS, various global terrestrial networks, and other observing systems and academia. Their inputs have been refined by GCOS expert panels, and also for a number of task teams on climate cycles and adaptation. These preparations are being combined to produce a first draft that was publicly reviewed early this year, and leading to the publication of the report following its approval by the GCOS Steering Committee. The report itself is comprised of a number of chapters. There's an executive summary that has been published separately as it's translated into the 6 UN languages. The main body of the report contains a chapter on observations of the Earth system cycles. This is an increasing focus as it enables us to both improve the understanding and forecasting of the climate, and also to ensure the consistency and comparability between the different variables that are being measured. There's a chapter on the status of the GCOS essential climate variables. These ECVs are a set of 54 variables that allow us to monitor and predict the Earth's climate. There's a section on satellite observations that are becoming increasingly important, then on the status of actions from the last GCOS implementation plan. A section looking at adaptation, extremes and mitigation considers the work that's been done so far by GCOS, and then this is all pulled together in a chapter on implications. The detailed assessment of each ECV and of the IP actions are included in separate annexes rather than the main body of the report. There have been many improvements in the global observing system since 2016. Satellite observations have improved their coverage both spatially and temporally. There are more variables being observed, and in general satellite data are accessible, well curated and discoverable to all users. WMO and its various members have ensured the required long-term monitoring continues for meteorological and atmospheric concentration variables, and observations of some of these atmospheric variables have improved over the last decade, largely due to technological developments. Many, but not all, ground-based networks are well managed with archives that are appropriately stewarded. The data centres and data stewardship is vital for climate data, as we need to develop and share long-term records of the climate information. A new development between GCOS and WMO is the establishment of a reference network for atmospheric and land observations. This is will be a set of sites that try and achieve the highest quality with highest standards, and all the measurements will be traceable back to international standards. This should improve the quality of the whole networks. The ocean observing community has been developing and improving their work over the decade. We have new best practices, data and metadata standards, and there's also been a decision to extend the Argo float program to the full water column, as the oceans are so important to climate. And again, various technological innovations have contributed to expanding the ocean observing system. These charts show the status of the observing system summarized into two things: the adequacy of the observing system, how well each ECV is observed, and how well the data is looked after, its availability and stewardship. This has been assessed in the three domains: atmosphere, ocean and terrestrial, and the marine habitat properties are presented separately, as they are a new area and so are not so well developed as the others. Data and availability and stewardship in general is better than the actual observation systems, but there are still areas for improvement. There are areas especially in the ocean and terrestrial systems, where the observations are of low adequacy and improvement is needed. The report also looks at and identifies areas for improvement. And these can be classified into four main groups. There's sustainability or lack of it. There are areas without good geographical coverage. Improvements needed in data stewardship, archiving and access. And finally, we need to develop more the support for the Paris Agreement, in particular adaptation and mitigation. Looking at sustainability, it's clear that some of the satellite observations do not have assured long-term continuity. They have been a major success, and this should continue into the future. For ocean and terrestrial observations, it's clear that sustained funding is needed. Many observations are only supported through short-term funding, which leaves the long-term records vulnerable. And a final point is that many otherwise successful projects have not led to long-term sustained improvements. Many projects in developing countries, where they do have a component on observations, don't have a long-term sustainability beyond the lifetime of the project. There are gaps in geographical coverage, in particular parts of Africa, South America, Southeast Asia, and this has not improved since the 2015 Status Report. There have been some GCOS regional workshops that have to be paused because of the COVID epidemic, but they identified some of the reasons behind this, including the costs of sustaining observations may far exceed national resources, particularly the case for the Pacific small island states. Sometimes there's a lack of planning for foreseeable expenses such as maintenance, consumables and so forth. There's poor staff retention and lack of trained staff, and at a national level often poor understanding of the national benefits of observations, which may lead to increased support nationally for observations. And finally, there are gaps in the ocean coverage in the Southern Ocean and ice-covered regions. There are gaps in the continental boundaries and in marginal seas. And there needs to be improvements in subsurface measurements, as these are critical to monitor and forecast the climate. Data stewardship, archiving and access is important. Most satellite data is fine. It's not true for all other ECVs. While many have good data archives, we need to ensure in the future that there are archives for every ECV that are sustainable with long-term adequate funding, that are consistent and have clear requirements, that provide data that is open and freely available, that perform some level of quality monitoring, quality assurance. They may need to allow the reprocessing of data where that's appropriate, and they should support data rescue, because accessing old data that's in paper or other difficult to access formats will allow us to extend the data records. And finally, supporting the Paris Agreement. Adaptation is a major area for observations to support. It's clear that currently the system can provide indicators for adaptation that could be used in the global stocktake. However, with some modest enhancement of products or new products, it could be used at a national level to add value to national adaptations. It could be used to assess climate hazards and vulnerabilities, assist in the identification of adaptation options, mitigate and implementation, and it can also manage, monitor and evaluate adaptation actions. Atmospheric concentrations of greenhouse gases can be used to support emission inventories, which are currently based on estimates from statistical data. They can be used to detect sources, they can validate emissions and removals, and also they can monitor the complete carbon cycle. Also, measurements can be used to support some mitigation efforts, particularly those on forests and land use. And finally, improving our understanding of the various climate cycles, such as the cycles of carbon and water and the energy balance, should improve our future projections. Looking forward, GCOS will produce an implementation plan which will be published in mid-2022. The report will be more focused on implementing organisations that will prioritise and support the Paris Agreement, adaptation and mitigation. We are currently collecting contributions and drafting the text, and there will be a public review in early 2022. And we would invite all interested parties to take part in that review, give us comments and feedback so we can improve the report as much as possible. So the GCOS Status Report is available from this web address, and I would invite you all to take a look at it and consider its contents. And finally, please remember to take part in the review of the implementation plan early next year. Thank you very much.